In the last video, we looked at the end behavior of the graphs of polynomials. In this video, we will take a deeper look at those polynomial graphs by looking at first their intercepts and how those intercepts behave. So let's just dive right in. How do you find the x and y intercept of any function? Always stays the same. For the y-intercept, you let x equal to 0 and solve for y. And for the x-intercept, you set y equal to 0 and solve for x. Why is that true? Well, if you're on the x-axis looking for the x-intercept, any point on that x-axis has a y-coordinate of 0. You have different values for the x-coordinate, but the y-coordinate is always 0. When you're looking at the y-intercept, any point on the y-axis has an x-intercept of 0. So that's how it works, whether you're finding the intercept of lines, parabolas, or anything else. So let's just give it a practice. So let's find the y-intercept by setting x equal to 0. So we're going to evaluate the function at 0. So everywhere there is an x, you have 0. Now, of course, you're multiplying by 0, so you should know it's 0, but if you want to see all those steps, you would have 0 times 4 times 1, which is 0. Now remember, that point is when x is 0, y is 0, so that is the origin. So that point right there, 0, 0, is not only a y-intercept, it's also an x-intercept. So let's look at those x-intercepts because sometimes there's more than one. So we want to set y equal to 0. Well, what does that mean? I don't see a y. F of x. We want to set our function equal to 0. So we want to say 0 equals x times x minus 2 squared times x plus 1. Before you start trying to multiply all that out, stop. This is in factored form. This is nice because now we can use the multiplication property of 0 and set each factor equal to 0 to solve for x. So I have x equal to 0, x minus 2 equal to 0, and x plus 1 is equal to 0. So that's that one, which we already knew about. This one we're going to add 2 to both sides and get 2. And this one we have x is equal to negative 1. But right now I want you to also notice that this was squared. So what does that mean? That really means that we had x minus 2 times x minus 2. We had it twice. So we actually call this a double 0 or a multiplicity of 2. Let's practice on this example because it's different. It's not in factored form, but the process is the same. So again, we're going to let x equal to 0 to find the y-intercept, and that's pretty easy. We get negative 3. So we know the graph crosses the y-axis at negative 3. But now we have to find the x-intercepts. So I set the function equal to 0. This is not in factored form, so we need to factor it. So since I have 4 terms, I'm going to use the grouping process. So I group those two and take out the greatest common factor of x squared. And these two have a negative 1 in common. Again, on grouping, those have to match exactly. If they don't, that means you need to go back to the beginning and regroup. But since they do, that is now the common factor. So if I factor that out, I'm left with x squared minus 1. Now at this point I could stop, but I know that's the difference of 2 squares, so I'm just going to keep factoring it. And now I have 3 different factors, and I can set them all equal to 0 and solve for x. So I have x equals to negative 3, to negative 1, and positive 1. So this graph crosses the x-axis 3 times. Okay, 3 times because I had 3 different factors. What if I had done this? and set x plus 3 equal to 0 and still got the negative 3 answer. But if I had x squared minus 1 equal to 0, would I have gotten the same answer? Let's see. I add 1, take the square root, and I get plus or minus 1, negative 1 and positive 1. So either way is correct, just be careful. So what we would hope is that we have problems that are factored because it makes this really easy, but that's not always going to be true. Now we're going to look at the multiplicity of those x-intercepts because that's going to determine how the graph behaves at those x-intercepts. If it's a single, or the factor was only one time, the graph passes through the x-axis like a line. So it just go like this, and it would just cross the x-axis. If it's a multiplicity of 2, or an even multiplicity, then the graph bounces off the x-axis like a parabola. So it could come down and go back up, or do that. It does not cross the x-axis, it does touch it in that one point. But if we have a multiplicity of 3 or odd, then we squiggle like a cubic function, like x cubed. So it could look something like this or like this. You need other information in the graph to know which way it goes. And that's how we're going to practice. For these examples, I'm going to ask you to do many things. We're going to get the lead term. I want to know the end behavior. I need to know the y-intercept, the x-intercept, and I want to graph it without a graphing calculator. Okay, so the leading term, that's what we did in the last video. So remember, we take each one of them in each parenthesis and then multiply them together. And so that's going to be x to the 6th. And so this is even. That tells me that the end behavior is the same and it's positive, so that means both up. So somewhere the graph goes up. Okay, the y-intercept is we're going to evaluate the function at 0. So we have 4 times 1 times 27. And I think that's 108. So somewhere way up here, we have 108. So now we need to look at those x-intercepts. So we set the function equal to 0. The good news is this is factored for us. So we can set each factor equal to 0 and solve. So I get x is 2, x is negative 1, and x is negative 3. But now we also need to state their multiplicity. So this is a multiplicity of 2 because that's squared. This is single because that was to the first power. And this is triple or odd. So this is even, single, and odd. So remember, even, it bounces. Single, it passes through. And triple is a squiggle. So how are we going to put those on the graph? Okay, so we have x is equal to 2, x is negative 1, and negative 3. This is obviously not to scale because 108, and that's okay. We're just looking for a rough sketch of the graph. Okay, start with one end. I'm going to start with the 2 since it's even and it bounces. So it's up here. It's got to come toward 2 and bounce up. So it's got to do something like that. So somewhere up. And then it's got to go all the way up to 108. Then we've got negative 1. Well, it's a single, so it's going to come on down and just pass through. It's not going to bounce, not going to squiggle. And then it's got to go from where you are down here to up here and passing through negative 3. So it's going to be down and then up. So let's just kind of connect those dots. It's not pretty, but I've shown that here are my intercepts, and I've got the end behavior right, and I know how it behaves at the x-intercepts, and that's what I'm looking for.